Hello, ladies and gentlemen. So now what we want to do is we want to do this problem together, okay? And basically what we want to do is we want to solve this quadratic equation, x squared plus 3x plus 2 equals 0, by factoring the expression on the left, okay? So now we have learned that when we want to factor an expression like this, or when we want to attempt to factor like this, we can immediately think in our brains a question to ask, which will enable us to factor this, to get the idea of how to factor this equation. I want you to think about it. Think about it a moment. Pause the video until you have it. Are you thinking it? Okay. If you recall from our previous examples, the question is like this. What two numbers multiply to give blank and add to give blank? And as we saw from before, we're going to ask what two numbers multiply to give the positive 2 here and add to give the positive 3. Okay, so it's always multiply to give the constant term and add to give the coefficient of the x term. Okay, and of course we're mindful of the signs, right? It makes a difference. So in this scenario, we want to find out what numbers multiply to give 2. So what we do is we make a multiplication table of the possible factors of 2. So we could have 1 times 2, and essentially that's it. We know that those are the only factors that 2 has. And it turns out coincidentally that if you add 1 and 2, you get 3. And so I claim that the factorization is going to be x plus 1 times x plus 2. Now I want to be clear here. We said that the numbers had to multiply to give me positive 2 here, right? So that means that it could have been negative 1 times negative 2, right? But we didn't choose that possible factorization because they need to add up to give us positive 3. If it had been instead the case that this had been x squared minus 3x plus 2, then it would have been that alternate scenario of x minus 1 times x minus 2. In this case, it's this scenario here, right? This is going to be our factorization of that, of the left-hand side, okay? Now you might say, okay, David, can you prove that to me? And I can say, of course, let's work it out together to make sure that this is in fact the factorization, okay? So I'm going to multiply these out. So x times x, that's x squared. X times 2 is plus 2x. 1 times x, that's plus x. And plus 1 times plus 2 is positive 2. And then, what is 2x plus x? 3x. Okay? So that's going to be x squared plus 3x plus 2. So what we've just verified is that this expression is exactly the factorization of this. Okay? And so what does that mean? That means that I can replace this expression in the equation with this factorization. Okay? So as we mentioned before, having secured the factorization of the left-hand side expression in this equation, we were able to replace it with the factorization. So now in this scenario, we have the number x plus 1 times the number x plus 2. Or I mean, strictly speaking, you might say, David, those are expressions, so you might want to say the expression x plus 1 times the expression x plus 2, and that's true. In this case, let's imagine that, or not let's imagine, we know that for any particular value of x, the value x plus 1 will actually be a number, and the number x plus 2 will actually be a number. And so what we can think of is the following possibility. Or we can think of the following question. If I have this number times this number equals 0, what do we know? We know that from the 0 product property, if two numbers multiply to give 0, then either one of them or both of them is 0. What does that mean? That means that either x plus 1 is 0 or x plus 2 is 0. Okay? If you look at this left-hand side, I can subtract 1 from both sides, and I get x equals negative 1. Okay? What about this right-hand side? I can subtract 2 from both sides, and I can see that the left-hand side simplifies to x. So x equals negative 2. Okay? And so our claim now is that these are our two solutions. So either x is equal to negative 1 and or x is equal to negative 2. Okay? So now one of the things I would like for us to do is I would like us to verify whether these are solutions or not. Okay? In other words, how do we know for sure that these are solutions? What does it mean for a number to be a solution of an equation? As we know, a number is a solution of an equation if it makes the equation true. So for example, in this case, if I evaluate the left-hand side of this equation at these values, if it simplifies to 0, then I know that it is a solution because it makes the equation true. So let's do that together. So if x equals to negative 1, okay? And by the way, one thing you might want to do right now is you might want to pause the video, try to evaluate it yourself, and then watch me do it once you've done it yourself. That's just a little helpful hint that you might want to try. In any case, so let's continue here. So if x is equal to negative 1, we can calculate the left-hand side as follows. X squared, so it'll be negative 1 squared plus 3 times the negative 1, because here the x is negative 1, and then plus 2. Okay? So we first ask ourselves, what is negative 1 squared? Negative 1 squared is negative 1 times negative 1. We know that a negative times a negative is positive. We know that 1 times 1 is 1. So it's just going to be positive 1 here, like this. Plus 3 times negative 1. What is 3 times negative 1? It's negative 3. Plus negative 3 means minus 3. And then I bring down my plus 2. Okay? Then I am faced with the following scenario. What is 1 minus 3? That's negative 2. Okay? So it'll be negative 2. That's from this piece here. And then I bring down the plus 2. And then from here, you can see if I have negative 2 plus 2, that's exactly 0. Okay? So we know for a fact now that the x equals negative 1 is in fact a solution of this equation because it makes this equation true. Now let us try the other alleged solution, the x equals negative 2. So if x equals negative 2, what happens? We're gonna replace the x's in this expression with negative 2. So the left-hand side of our equation, which we abbreviate as LHS for left-hand side, is equal to negative 2 squared, okay, plus 3 times negative 2 plus 2, and then we're going to simplify this. Okay, let me fix this here. Beautiful, perfect. So now we need to ask the question, okay, what is negative 2 squared? Negative 2 squared is negative 2 times negative 2. A negative times a negative is a positive. 2 times 2 is 4. So this gives us positive 4. Now we're going to add 3 times negative 2. What is 3 times negative 2? That's negative 6. We're adding a negative number. Well, that's the same thing as subtracting that number. So in other words, minus 6 plus 2. Okay? So now what I want you to imagine is this. What is 4 minus 6? 4 minus 6 is negative 2. So I'm going to put that here, negative 2, and then I'm going to bring down this plus 2. Okay? Now, what is negative 2 plus 2? That is also equal to 0. Okay? So what I've just shown you here, okay, let me show you how this worked out. So this simplified to the negative 2. Okay. So what we have seen is that these are in fact the solutions to this quadratic equation. Moreover, we know that for any quadratic equation, that is, any polynomial with whose biggest degree is 2, can have at most 2 distinct solutions. Now, it doesn't have to have 2 solutions. It could have 1 solution, Um, but it does have a maximum of 2 solutions. And so in this case, having found 2 distinct solutions, we know that there are no more solutions to be had. We have them all, as we just verified here. And these are them. And again, we solved this one by factoring because we were able to express this as the product of 2 linear factors. Okay? Anyway, I hope you've enjoyed this example, and I look forward to seeing you again soon. Thank you so much.